Retrieval Augmented Generation or RAG. Nowadays, this RAG is revolutionizing the way we interact with machines by enabling natural language conversation that feel like chatting with a friend. However, making these interactions accurate, safe, and efficient requires some innovative techniques beyond traditional algorithms. So, that is why researchers are exploring four exciting avenues: re-rankers that refine top candidates for optimal responses, then long horizon reasoning that goes beyond short term dependency to uncover hidden causes and effects, then guardrails that keep answers grounded in reality and protect confidentiality, and efficient context management strategies that minimize resource consumption while maximizing performance. So today we'll understand all these four concepts. So let's get started. What is the re-ranker? Now, this in the field of natural language processing, re-rankers in retrieval augmented generation is a technique used to improve the accuracy and relevancy of generated responses by combining information from multiple sources. Essentially, it involves retrieving relevant passages from a large database and ranking them based on their similarity to the input query before selecting the best response to provide back to the user. Well, this approach allows for more diverse and contextually rich answers than relying on a single source alone. There are two types of re-rankers. So when we try to find what we need using a computer, sometimes it shows us a lot of options, but we still can't understand to find exactly what we want. To solve this problem, there are two types of re-rankers that can make the things better. The first one called score based, which combines scores from many different sources to rank the result in order to how helpful they might be. And it works kind of like adding up points to choose the best answer. The second type called neural network based, which uses a special program to figure out how closely connected a question and an answer are. So by doing this, it helps improve the quality of the results shown to us. And both type of re-rankers can make our searches faster and easier, which helps us to get what we need quickly and accurately. So to understand re-ranker, let us say a user asks a question like, which coffee shop near me offer free Wi-Fi? So a RAG system would first search its database for relevant passages which contain the information about nearby coffee shops and their amenities. So it might retrieve passages from the business directories, restaurant review sites, and social media platforms. The system would then rank each passage according to how closely it matches the user's query, taking into account factors such as location, keywords, and sentence structure. Finally, the highest ranked passage would be presented back to the user as potential answer, along with a confidence score indicating their likelihood of being accurate and useful. So in practice, RAG has shown promising results in various industrial applications including chatbots, virtual assistant, and document summarization system. Then comes long horizon reasoning. Now this long horizon reasoning in retrieval augmented generation is an extension of the RAG technique that enables machine to understand complex relations between the concept over extended period of time. So while standard RAG relies mainly on matching surface features between queries and documents, now this long horizon reasoning RAG goes beyond that by considering the temporal context of events and entities which are mentioned in text. So by doing so, it can generate more insightful and coherent response to open domain questions that require long range dependency, such as involving cause effect relations or trend analysis. So to understand this long horizon reasoning RAG, consider a scenario where a user asks, can you recommend any stocks that are likely to perform well in the coming quarter due to a recent policy changes? So the traditional RAG may struggle with answering such a question since it mostly focuses on local patterns within sentences rather than broader terms across the text. But with this long horizon reasoning RAG, we can identify relevant documents from news articles, finance reports, and market analysis, which spanning over several quarters or years, and using sophisticated machine learning techniques to infer causality and forecast future performance based on historical data. So after evaluating various functions, long horizon RAG could deliver a confident and compelling answer to the user. So overall, this long horizon RAG shows great promise in helping businesses make better decisions by providing deeper insights into complex phenomena using vast amount of available digital content. Next comes the guardrails. Now, this guardrails in retrieval augmented generation refer to constraints imposed on the output of the model to ensure safety and reliability. They act as boundaries that prevent the generation process from producing misleading, incorrect, or potentially harmful results. So, these guardrails help mitigate risk associated with generating novel and creative responses that could deviate too far from the truth or violate sensitive information disclosure policies. For instance, suppose a user asks a question related to personal health, such as how often should I get a mammogram screening after turning 50s? So instead of simply regurgitating specific numbers or dates, and RAG system equipped with the appropriate guardrails would filter the candidate responses against established medical guidelines and patient histories to ensure the recommended frequency aligns with individual risk profiles and prior diagnostic findings. Additionally, the model could also incorporate privacy settings which is specified by the user regarding which type of information they prefer not to share with others. Next comes efficient context management strategies. Well, this efficient context management strategies in retrieval augmented generation or RAG refers to methods which are designed to enhance the ability of AI models to handle contextual nuances and ambiguities in human languages while minimizing computational resources required during training and execution. Since RAG involves processing massive volumes of textual data, efficiently managing context becomes critical to achieve both speed and accuracy in generating meaningful and relevant outputs. So one popular strategy which is employed in this area is BERT, or the bidirectional encoder representations from transformers, which uses self-attention mechanism to capture semantic connections between different parts of sentences without explicitly specifying the relation between them. Another effective method is robot or robustly optimized BERT pre-training approach, which further improves upon BERT through advanced pre-processing steps and fine-tuning procedures tailored to particular tasks such as question answering, sentiment classification, and named entity recognition. Thank you.